So for this first assignment, hopefully you already had an opportunity to read through the description, but basically you're gonna extend a matrix library that we provide. And this is the matrix library provided by the book, actually, by the Leia Matsuda book. And the exercise here is to extend that library to implement basic linear algebra functions. So we want you to be able to implement vectors and then have vector operations and some simple like matrix vector also operations. So I won't read the whole description here, but basically all our labs, they have the same structure. We have some video instructions in the beginning. We're gonna have some objectives, and here we have an introduction of what you have to do. And normally this is the most important part, which is the instructions. We try to be as clear as possible on the instructions. So if you follow this, each instruction should match the rubric points, and so you should have a clear idea of like where you are at in the assignment and how many points you're gonna get if you deliver whatever you have so far. So you can expect something like that for all the assignments. So for example, this one, you have the first instruction, which is set up to draw a rectangle example from the book with our matrix library. Right? And then we have some other sub instructions here, and you get this expected result. So you can compare of like what you're getting. Quick reminder, these instructions, they are not necessarily how you have to, like this is not mandatory steps. So these are just guidelines to help you like kickstart your solutions. And you'll see that as you move forward in this course, you're gonna be able to you're gonna get used to these assignments, and then probably gonna have your own ways of starting it. But this is like our instructions, is like our guidelines. Yeah, so people also sometimes have questions of like, oh, for example, so this instruction here is worth 1 point. So but if you keep reading, some next instructions, they actually override your work. For example, here you have to draw a rectangle, and then at some point now you're drawing a vector, so you don't have that rectangle anymore. And then people ask questions of, okay, but how are you checking that we did the first part? So for some of them, we won't check like if you have a blue rectangle here, we are assuming that if you got to this point, you actually did this point, because you have to do something to get to here. You actually have to do something like this. So you're gonna get this point anyways, right? So you don't have to show us all these things. And so yeah, so for today, for this assignment specifically, I think I'm gonna go ahead and show you my solution to it, so you have an idea of what to deliver at the end, and then we can actually ask questions from there. And then if you don't have questions, I'm gonna move forward to the introduction to JavaScript, and then during that introduction, I'm gonna talk about most of the things you're gonna have to use for this assignment. So let me bring I have my solutions here. I think I have. So yes. Let me see if I have. Yeah, I think this one is going to work. Let me just use the same screen here. Oh no, this is. Oh, sorry, this should be not this one. This should be Spring here. Yeah, I think I can do this one. So yeah, basically the assignment, it's gonna look like this. You're gonna have a black canvas. So when you're finished with the assignment, you should have like a black canvas like this, where you can type here vector ones and vector twos in a second vector. So for example, you can say here, I don't know, 5, 0, and then here you can say 0, 5. So this is the vector v1 with coordinates x and 0. This is v2 with coordinates 0 and 5. And once you hit draw, you should see the vectors there. And then you can you can, for example, if you press draw here, you're adding this operation. So if you press add here, what's going to happen is you're going to see as in green here the result of this of the add between V1 and V2, and here you'll be able to select different operations. So if I do subtract, I see the subtract result. I can do multiply. In this case, I'm multiplying by a scalar. So for example, I have to put a scalar here too, and then both of them get multiplied. Right? For example, so if I put 1.5 here, we should see better. So now I see the result of those two vectors multiplied by 1.5, and so on. And for example, angle between is going to calculate the angle between these two vectors here. And let me redraw this thing. Basically, the angle that I want is the angle between the blue and the red vector. So the result of this operation should go to the console. So every web browser has a JavaScript console, and in Chrome you can just double click and press inspect, and then you're gonna get this tab here. So if you select console, you're gonna get the console there. So there's a way to print to that console. I'm gonna talk about it during the slides, but basically, let me just show you how it works. If I press here draw now, basically I get the angle there as 90. Okay, so the same for the area. So in this case, we want the area of the triangle formed by these two vectors. So in this case, the area of the triangle is 12.5. Okay, and what else? We have the magnitude. Also, here we're going to print the magnitude of V1 and V2, which is 5, right? We can clearly see that here, because y is 0, in this case x is 0. We can see that the length of magnitude is the same as length, so the length of both of these vectors are 5 units. And we normalize, then you should see here those two little vectors that we created. Normalized vectors are these vectors. When you normalize a given vector v, you get another vector v prime with the same direction but magnitude 1. Okay. So those are the operations we want. So at the very end, we should get something like this. I like showing that so it gives you a clear idea of what to expect and what to deliver. Okay. So don't worry about the exact strings being the same here. You don't have to follow exactly the same strings. Let's say angle, you can say angle of the triangle. Those are not super strict, but it's just like we need all these features to be there. If you get all the features, you get all the points. Any questions at this point?